Okay guys, I'm sorry the last video about domain restriction got cut off. My flash drive was full. I had to go delete a few old videos and make room for this one. So this continues what we were doing in the previous domain restriction function, the previous video, okay? So we were graphing this function right here, f of x equals -4, and we talked about remembering that whenever we have y equals a constant or f of x equals a constant, it has to be a horizontal line. So if you want a quick review of this, go to my previous video, domain restriction, okay? We want to graph f of x equals -4. We need to graph this f of x function up here, but there's a restriction. It has to be between 0, not including 0, because I don't have an equal sign here, but all the x's that are less than or equal to 6, including 6. So pretty much between 0 and 6, if I look at my x-axis over here, I want it between 0 and 6. Okay, I like to shade my domain here. My graph better just be between this shaded area right here. I need to pay close attention to the not including 0, but yes, include the 6. Now this is not graphing, I'm just shading my domain, meaning if I could just zoom in on both sides of my function, I would only see this portion of the graph. That's exactly what we want to see. We only want to see a portion of the graph, piece of the graph. So let's go ahead and graph f of x equals -4. It would be, if I had no restriction, it would be a line that starts right here and goes infinitely left and right. But I can't. There's a restriction. I need to stay between 0 and 6 and stop right here. Okay? But then I need to pay attention to the critical points on each of the sides. So includes the 6 means I want the x equals 6. I would have a closed dot right here. So there's my closed dot right here because I do want to include the 6 right there. And then x is between 0. 0 is less than x. I don't want the 0. There's no equal, so I would put an open circle right there. Now my graph is complete. I graphed it between 0, not including 0, all the way to a 6, including a 6 is closed dot. So that is our domain restriction graph of f of x equals -4. Okay? So it's paying attention to what the graph looks like, identify the function, and then paying attention to the restriction that they want us to do for the x values here. And that's it for that one. Okay, I also promised that I was going to do number, which is a little bit difficult. Let me find here. I made a note to myself. Number 3, 5, and 11. That's the other one I promised I would do. Let me see what 11 looks like. I apologize. Here's what 11 looks like. Okay, so number 11. Okay, number 11 looks like this. F of x equals 2 to the power of x. Is it -1? No, it's just the power of x. Sorry, let's erase that. It's just the power of x minus a 1 out here. Okay? So that's what they want us to graph. And it says graph f of x if between x's are between -1, not including the -1, and includes the 3. So again, similar to our previous f of x function, you are restricted to graph this function, but only between -1 and 3. Okay? So first, my step number 1, let's discuss. Let's just brainstorm here to identify the function that we're going to be graphing. Okay? What kind of function do we have here? I ask myself questions like that. I look at this and I say, it's an exponential. Okay? And exponentials look like, in this unit, we have increasing exponentials, and they look like a J. It is going to be shifted. We talked about translations, It's going to be a function like this, but shifted up on the x-axis and the y-axis. So something, it's an exponential function that's going to be shifted. So I've got to remember this shape. Okay, so second thing I do that I mentioned before is I need to always evaluate, if I can, evaluate the function, evaluate f of x, add the critical points. Add the critical point or points. In this case, there are two of them. So I better pay close attention to these 2 points right here. What happens to my function at -1 for x? So what happened at -1? If I plug in a -1 for x, what happens? So why don't we go ahead and plug in? So 2 to the power of, instead of an x, now I have a -1, and then minus a 1. Okay, there's a rule of exponent that says whenever I have a negative exponent, I can put in the denominator 1 over 2. Instead of a -1, now it's +1. So this becomes 1 over 2 to the first power, minus a 1. So what is 1/2 minus 1? With common denominator here, this would be 2 over 2. So this would be 1/2 minus 2 over 2. And then I can just do this little subtraction, and we would get -1/2. So when I plugged in a 1, when I plugged in a -1, I got a -1/2. So that is one of the points of my graph. As a matter of fact, that's the lower bound here of my graph, the lower restriction of my graph. What happens at 3, at x equals 3? That's a much easier number to work with than a negative exponent. 2 to the power of 3 for x minus a 1. So 2 to the third power, it's 2 times 2 times 2, right? It's 2 times itself 3 times, which would be an 8. And then 8 minus 1 equals a 7. So when you plug in a 3, evaluate the function at a 3 for x, you get a 7 for y. So I have these 2 very, very important points. Let me put little stars here, because those 2 points are the end, the cutoff. I like to call it the cutoff of my graph. My graph is cut off at both ends here. Okay, so let's go back here with this 2 little piece of information in mind. Let's go ahead and create our graphing plane here. We have positive infinity. Let's do 1, 2, 3, 4. -1, -2, -3, -4 to negative infinity. Let's do a -1, -2, -3. I'm going to go to negative infinity here. 1, 2, 3. Let's go to positive infinity here. Okay, so I like to label it so we can carefully find these important points. So let's go ahead and put this one right here. -1, comma, -1/2. So -1 for x, we got -1/2. Between -1 here and 0, we would find -1/2 right here. I apologize. This is an open circle, because we're not including the -1. So it should be an open circle right there. I know it's supposed to be a J shape, remember. And then my other point is this 3, 7. If you plug in a 3 for the function, you're going to get a point way up high. 3, 4, 5, 6, 7, let's pretend is up here, which it should be higher. I put a closed dot. Again, let's pay attention to the restriction, because we have an equal. So that's closed and that's open. So I'm pretty sure if you want to evaluate to have a more accurate graph, if you plug in a 0 for x, you can do that on the side. What happens if I plug in a 0 for x? So 2 to the 0 minus a 1 would equal, so 2 to the 0, any number to the 0 power is a 1, minus a 1, it would equal 0. So we do have to touch 0, 0 right here. And then here I would have a more accurate graph looking like this. Okay. Unfortunately, my paper here does not have a nice grid, but it should look a nice little shape J going up this way really high. But that is giving the circumstances of just a paper with no grid behind. This looks good. Okay, so there's the restriction. I stayed between -1 and I stayed between 3, and there is my piece of my function, okay, a restricted function. So I hope these 3 examples helps you with domain restriction. Always paying attention to this open and this closed stuff. Equal means closed. There's no equal means open. You have to always be paying attention to the ends of the graphs, where to start, where to end, okay? All right, guys, good luck on this domain restriction. I'm going to do one more video for the review. I want to work some review problems to make sure you have plenty of resources to help you. All right, thank you.